All right, the next lesson is parent functions and transformations. So a parent function is just any function that we can change. Like this line right here, right? That's the coordinate plane. The plus sign is the coordinate plane. This crooked line here is a function. Let's say it's equal to y equals x. Well, look at that. Look, it hits the line, the y-axis down here. So we're going to say it's y equals x minus 1. Y equals x minus 1. If I took this and moved kept the line with the exact same slope and moved it up here, now it's at y equals x plus 3. I know there's no like cross line, no marker lines there to mark what the numbers are. This is just an example. But so this is the original line right here, and I moved it up by what? 4 points? Because I moved it up to the 0 is 1 point, and then up by 3 more points is 3 plus 1 is 4. So I moved it up by 4 points. That's called a vertical translation. Vertical translation means it moved up and down the y-axis. Similarly, I could do another one down here and call it y equals x minus 6. I moved it down 5 notches. Actually, almost looks like the exact same amount. I moved it down. Let's call it x minus 5 because I moved it down 4 instead of up 4. Now, those are part of a family of functions. They all have the same slope, and they all came from this original parent function right here. This one's more concept work. I'm not going to do a whole lot of math and moving numbers around the equal sign this time. Sorry for the shaking. That's just my Jimmy legs get one. Okay, so just to recap, the important thing here is that we kept the slope and changed the intercept. The slope is the same in all three of these, but we changed the intercept. Now for this next one, for rotation, we're going to do the opposite. We're going to keep the intercept and change the slope. Okay, so here's two more. Here's the coordinate plane, of course. Now this is my original line, right here. This one. And it's at minus 1. And let's say it was x. Y equals x minus 1. Or f of x equals x minus 1. Basically the same thing. F of x is y is f of x. They're the same term, just expressed differently. They're synonyms, you could say. Now this line right here is still crossing at negative 1. See that? That's where they're touching. Still crossing at negative 1, but it's got a different slope. It's moved down slightly. So it's y equals 3x minus 1. If I moved it up like that, I could say it was y equals 1/3 x minus 1. And that is a rotation. You see how the line is rotating around the point being where it touches the y-intercept? It's rotating around that point. And it's based on the slope, on the differing slope. Okay, so if they give you an equation, if they say f of x equals x plus 1 is transformed, right? They just use the generic term transformed into f of x equals 3x plus 1. If they say that, if they go, this is transformed into this, what happened? You say it was rotated around the point 0, negative 1. Does that make sense? Because it's rotated, because it's messing with the slope, not the y-intercept. If it messed with the y-intercept and left the slope alone, like in the last one, then you would say it was translated vertically by however many points that number changed. And finally, the third type of transformation is a reflection. A reflection happens when you negative the slope. So you've got something like f of x equals 3x plus 1. If you take that 3x and multiply it by negative 1, like so, right? You've got the 3x, you can make it a negative 3x. And what that does, let's see, that would be like this. This is the parent function. And if you negative the slope, it's going to keep it pointed here. Oop, that is a backwards arrow. There you go. And then that is what it does. It reflects it across the y-axis. It's pointing like this, and now it's pointing like this. And all we did was negative the slope. Just negate it. Flip the sign. Keep the number, flip the sign.